Hello students, I am Srikanth. We are discussing programming in C language about the topic program fundamentals. The agenda of this session is about compiler, interpreter, assembler, linker, relocation, loader, process of compilation, source code translation into executable code and suitable examples. Okay, so we had discussed in detail about compiler, interpreter, assemblers in the previous video session, right? Here just you try to observe what is compiler. A compiler translates the program written in what? High level language into machine language. Compiler is a language translator. It converts what? High level language into machine level language. Compilers like GNU compiler collections like GCC, several compilers like ADA compilers, ALGOL compilers, C compilers, C++ compilers, like every programming language consists its own compiler. Okay, already I discussed in detail about these compilers in the previous video sessions. Okay, interpreter. Interpreter is a language translator. It translates the program line by line while the program is running at a runtime. Several runtime, so it provides several runtime environments like basic interpreters, GW basic, Perl interpreters like active Perl interpreter, active TCL, VMS interpreters like Rex interpreters, and so on. These are all what? Various interpreters. Okay, so about interpreter also I discussed in detail about the previous video sessions, in detail about what is interpreters, how it functioning, what are the steps involved for interpreters, what are the various languages doing interpreter based programming languages. I given in detail explanation. If you missed this video, kindly go through that one. Okay, about assembler. See, assembler is a language translator, second generation language, assembly level language. There, assembler is a language translator. It translates what? Assembly language instructions into what? Machine language. Okay, the example like assemblers, Intel 86 netwide assembler, and so on. See, these are all what? Various assemblers are there. It is used in what? Second generations of programming language. Okay, see, assembly language is also what? Low level language, but it is the top of what? Machine language. Here assembler is a language translator, converts assembly language into machine language. Here we are using what? Symbolic representations like mnemonics. Okay, like add, subtraction, load, like that. Okay, so these assemblers also we discussed in detail in the previous video session, like compilers, interpreters, assembler. I had discussed in detail about how, what is that language translator, how it is functioning, what are the various examples, terminologies, function. I given in detailed explanation with real-time examples. Okay, if you missed the session, kindly go through that once. So in this session we'll focus more on about linker. Okay, see, what is a linker? In a high level language, some built-in header files or libraries are stored. These libraries are predefined and these contains basic functions which are essential for what? Executing the program. These functions are linked to the library by a program called linker. If linker does not find a library of a function, then it informs to compiler, and then compiler generates an error. The compiler automatically invokes the linker as the last step in compiling a program. See, not built-in libraries, it also links the user defined functions to the user defined libraries. Usually a longer program is divided into what? Smaller subprograms called what? Modules. And these modules must be combined to execute the program. The process of combining the modules is done by the linker. Okay, see, simply can remember here, linker or link editor is a computer system program that it takes one or more object files like generated by a compiler or an assembler and combines them into what? Single executable file called library file or another object file. See, linker can take object from a collection called a library or runtime library. The linker also takes care of arranging the objects in programs address space. Example like GNU linker, GNU ID, Unix commands. There it is going to be using. Basically, linkers are categorized two types like static linking, dynamic linking. Static linking is the result of the linker copying all library routines used in the program into the executable image. See, this may require more disk space and memory than dynamic linking, but is more portable since it does not require the presence of the library on the system where it runs. Observe here, this is the linker. It provides runtime environment. It's going to be binding all the different objects as a single object, and it also loads for some libraries, DLL and executable files. This linker is going to be generated what? One executable file, combining or getting this objective file as generating what? One executable file. See, differing the resolution of some undefined symbols until a program is run. That means that the executable code still contains undefined symbol plus a list of objects or libraries that will provide definitions for these. Loading the program will load these objects or libraries as well, and performing a final linking is called dynamic linking. Generally, what this object consists, already we know about object is nothing but what? Like binary code or machine understandable code. Say after compiler or assembler is going to be generating what? Those language translator converts high level language into what? Or assembly language into what? Object code, right? This object code is machine understandable code. What it contains? Generally it contains what? It is defined external symbols, sometimes called public or entry symbols, which allows it to be called by other modules. Undefined external symbols, which refers other modules where these symbols are defined. Local symbols used internally with the object file to facilitate relocation. See, normally our object file can contain three kinds of different symbols. See, this is about linker. Okay. So linker or link editor is a computer system program that takes one or more object file and combines them into what? Single executable file, library file or another object file. Simply can remember, linker is responsible to convert that object file into what? Executable file. Okay. Next, relocation. See, relocation is the process of assigning load address to what? Various parts of a program and adjusting the code and data in the program to reflect the assigned address .df. A linker usually performs relocation in conjunction with symbol resolution. The process of searching files and libraries to replace symbolic reference or names of libraries with actual usable addresses in memory before running a program. Relocation is typically done by the linker at link time, but it can also be done at runtime by a relocating loader or by the running program itself. Some architecture avoid relocation entirely by deferring address assignments to runtime. See, this is known as what? Zero address arithmetic. Generally, relocation consists two steps. Okay, each object file has various sectors like code, data, like some extensions like .bss and so on, to combine all the objects to a single executable. The linker merges all sections of similar type into a single section of the type. The linker assigns runtime address to each section and each symbol at this point. The code is nothing but function, and data like variables will have unique runtime addresses. The second point, each section refers to one or more symbols which should be modified so that they point to the correct runtime address based on information stored in a relocation table in the object file. Okay, just you can remember, relocation is a process of assigning load address to various parts of a program and adjusting the code and data in the program to reflect the assigned addresses is nothing but relocation. Say another terminology in the programming, loader. Loader is a program that loads machine codes of a program into the system memory. In computing, a loader is a part of operating system that is responsible for loading programs. It is one of the essential stages in the process of starting a program because it places programs into memory and prepares them for execution. Loading a program involves reading the content of executable file into memory. Once loading is complete, the operating system starts the program by passing control to the loaded program code. All operating systems that support program loading have loaders. In many operating systems, the loader is permanently resident in memory. A loader is a system program that accepts objective programs and prepare them for execution and initiates the execution. See, generally the functions performed by the loaders like assignment of load time storage area to the program, loading of program into assigned area, relocation of program to execute properly from its load time storage area, linking of programs with one another. Simply you can call a loader is a program that places a program's instructions and data into main memory like primary storage location. An absolute loader places these items into the precious location indicated in the machine language program. It precise locations indicated in the machine language program. A relocating loader may load a program at various places in primary storage depending upon the availability of primary storage area at the time of loading. A program may be relocated dynamically with the help of relocating register. This is about what? Loader. Loader is a part of an operating system that is responsible for what? Loading programs and libraries. So it is one of the essential stages in the process of starting a program as it places program into memory and prepares them for what? Execution. See, just only we discussed, right, about a linker. What linker does? Linker is going to be linking this object file and generated what? Executable file, and also it links with some shared libraries of inbuilt libraries, and generating executable file. Once executable file is generated, loader is responsible to load that executable file, and it's going to be places into what? Main memory. See, loading a program involves reading the contents of the executable file containing the program instructions into memory, and then carrying out their other required preparatory tasks to prepare the executable for running. Once loading is complete, the operating system starts the program by passing control to the loaded program code. See, loading is a process of bringing a program from secondary memory to what? Main memory. See, normally where we write the program, we are writing the program, save the program in what? Hard disk, right? Internal hard disk, as we discussed in the memories. But from where, who is going to be executing instructions? Processor, CPU, central processing unit. CPU always looks which memory to execute the instructions, main memory or secondary memory? Main memory. Even we are storing the program into the secondary memory, but processor cannot go to the secondary memory, cannot execute because time taking, okay, execution performance degrades. For that sake, always CPU looks out main memory for executing the instruction. See, someone need to load that, right, from secondary memory to what? Main memory. Who is the responsible? That is done by a loader. Okay. See, loading is a process of bringing a program from what? Secondary memory to what? Main memory, so it can run. The system software were responsible for it, known as loader. The simplest type of loader is what? Absolute loader, which places the program into main memory at the location prescribed by the assembler. Like we had discussed in the DOS, right? Like bootstrap loaders, right? Is an absolute loader which is executed when computer is switched on or restarted to load the operating system, like loader.exe. An auto start program loader optionally used in the startup process of what? Microsoft Windows ME. Like bootloaders like loader.com, a multi bootloader shipping with various digital research like Novel, IMS, Caldera, etc. DOS based operating systems like multi-user DOS and DRDOS. Loader.c is part of a loader.com installation. See, we had discussed in detail about what? Bootloaders, what is booting process, everything in the previous video sessions, right? See here, a loader is a system software that places executable program instructions and data from what? Secondary memory into primary memory. and prepares them for what? Execution, and initiates the execution. That's it. That is done by a loader. Okay. So now we'll discuss in detail about what is the process of compilation. Okay. Here you can look it out. Source program is nothing but user understandable instructions, like high level instructions we are writing in a source code or source program. After that, who should convert that high level language into machine understandable language? As we discussed about language translators like compilers and interpreters, we had discussed. But here in this session, I am discussing in detail about how this compilation is going to be happens. What are the terminologies in between? We try to discuss one by one. Okay. So once we return the source code, like user understandable code or high level instructions, we return as a program based on the particular programming language. We followed some syntax and semantics, we constructed a program. So that is in a high level language. But machine understood is always what? Machine understandable language represented by zeros and ones. Okay. Here, what is the steps involved? Lexical analysis. See, lexical analysis in this phase, the source program is scanned for lexical units known as tokens, namely identifier, operator delimiter, and so on, and classifying them according to their types. A table called symbol table is constructed to record the type and attributes information of each user defined names used in the program. This table is accessed in the other phases of what? Compilation. This is the first step called what? Lexical analysis. The source program is scanned for what? Lexical units known as what? Tokens, like identifiers, operator delimiters, and so on. Okay. What is the second step? Syntactic analysis. So in this phase, tokens are conflated into syntactic units such as expressions, statements, and so on, that must conform to the syntax rule of the programming language. This process is known as parsing. Syntax is similar to the grammar of a language. Syntax rules specifies the way in which valid syntactic elements are combined to form the statements of the language. Syntax rules are often described using a notation known as BNF, Backus Naur Form Grammar. Every programming language having their own syntax and semantics. Remember it. Okay. This is done by what? Syntactic analysis. The third step, semantic analysis. The semantic of a statement in a programming language define what will happen when that statement is executed. Semantic rules assign meanings to valid statements of the language. What semantic rule is about? Assign meaning to valid statements of the language. In the semantic analysis phase, the parsed statements are analyzed further to make sure that the operators and operands do not violate source language specification. Okay. The next one is called intermediate code generation. See, to make the target program a bit smaller or faster or both, many compilers, language translators like compilers, produce an intermediate form of code for optimization. In most cases, the intermediate code is generated in assembly language or in a different language at a level between assembly language and machine language. Okay. Next, code generation. This is the final phase of a standard compilation which converts every statement of the optimized intermediate code into target code using predefined target language template. The target language template depends on the machine instructions of the processor, addressing modes and numbers of registers. Okay. After that, it's going to be generated what? Object program. This object program, just we discussed in previous sessions, like bytecode instructions or machine understandable instruction. Who is the responsible to load this object code? That is done by what? Linker. See, just only I discussed, right? Linker is responsible to load what? Object code, means machine understandable code or intermediary code. After translating this compiler or assembler, that code is going to be loaded by linker. Linker once loaded that code and generating what? Linking and generating what? Executable code. That code is going to be loaded by loader and start for what? Executing the program. Loader is responsible to load that executable code and uh, transfers for secondary memory into what? Primary memory, and providing what? Execution. See, this is the general process of compilation. Up to this is what in detail of compilation, up to generating program, objective program. After generating objective program, these steps involved for what? Runtime environment. Remember, for any programming language, any high level programming language, it may consist two environments. One is called compilation environment, another called runtime environment. This compilation process involves these lexical analysis, syntactic analysis, semantic analysis, and generating intermediate code generation and code generations. This is what steps involved. Okay, next, source code translation into what? Executable code. See, in this, here I explained in detail about what? Complete process of compilation, but here generally what happens in the compilation time and runtime in the different programming, high level programming languages environment. Okay, so try to concentrate. Source program or source code means high level instructions written in the one program for providing a solution of particular problem. Okay, so that is called source code or source program. This is understood by user but not machine. Machine always understands what? Low level language called binary language represented by zeros and ones, as we discussed. Here, language translator. Compiler is what? Language translator. What is the job of compiler here? Compiler loads this source code at a time and compilation is going to be started. This compiler is responsible to check syntax and semantics of the particular program. If anything went wrong, syntax or semantics, immediately it throws an errors. That error is called compile time errors. Okay, so if it is compile time error is free, until unless compilation errors are free, we cannot execute the program. Remember in this point. Okay, this point is very important. So many students are failed to compile and unable to get the output. They are asking, sir, we are not getting output. How you get output? Until unless successful compilation, you cannot get output. Remember it. Okay, here compiler is responsible to compile this program, converting high level language into machine understandable language is called objective code. When it generates object code, when error is free, compile time errors are free, then only compiler is responsible to generate high level language into what? Machine understandable code called byte code or object code. Compiler does here two jobs. One is checking syntax and semantics of the particular programming language. Every programming language consists its own compiler. Some languages are compiler based languages, right? Those languages have their own compiler. That compiler checks syntax and semantics of the particular code written by user. Okay, second job done by compiler, it converts what? High level instructions into what? Machine understandable instructions. These machine understandable instructions are called object code or byte code. This code user cannot understand. Even you can open this file, but you cannot understand. This code is understood by what? Machine. Okay, who is the responsible to send this object code to machine code or executable code? Linker. Linker is responsible to load this object code and linking and generating what? Executable code. Once executable code is generated, loader is responsible to load that executable code from secondary memory into the main memory, because processor always execute instructions in the main memory. For that sake, loader is responsible to load this executable code and it going to be placing into the main memory and start for providing what? Execution. After that, if it is successfully executed, it going to be generated what? Output. Otherwise it throws what? Runtime errors. Up to here it going to be generate compile time errors. After that, in these areas it going to be generate what? Runtime errors. Like there is a problem of linking and loading, you may get what? Runtime errors. Remember it. These 2 points are very important for compilation and running the program. Okay, here we are writing the program. After writing the program, we need to compile it, after that we need to execute it, but we are not doing physically all these things. See that internally these translators like compiler is responsible to do, and internally linker and loader that responsible to linking and loading and generating execution files and executing the programs. Okay, so this is about in detail explanation about what source code translation into what executable code. Okay, when we are discussing about C programming language, there I will explain in detail about C execution flow in detail, but this is what generally source code translation into executable code, like source program, high level instruction, language translator called compiler. Once successfully compiled, entire source program is converted into machine understandable code or object code. Linker is responsible to load this object code and generating what executable code. Loader is responsible to load this executable code and placing into the main memory. Processor is responsible to execute that instructions and providing what output, and it generates what output. Okay, this is a very simple explanation about source code translation into executable code. Okay, here in the previous sessions I explained in detail about what compiler, but I try to give some more brief, okay, brief introduction about what compiler. See, as we know, compiler is a language translator. It translates the program written in what high level language into what machine language. Generally a compiler consists three things normally, that is called front end, middle end and back end. So just only we discuss these lexical analysis, semantics analysis, syntactic analysis, right? Exactly that, those things. The front end means what? It verifies the syntax and the semantics and generates an intermediate representation or IR of the source code for processing by the middle end. It performs type checking by collecting type information, generates errors and warnings if any in a useful way. Aspect of the front end include lexical analysis, syntax analysis and semantics analysis. So just only explained about this lexical analysis, syntactic analysis and semantic analysis. These are all comes under what front end in the compiler. Okay, next, middle end. It performs optimizations including removal of useless or unreachable code, discovery and propagation of constant values, relocating of computation to a less frequently executed place, or specialization of computation based on the context generates another IR of the back end. The back end generates the assembly code performing register allocation in process, optimizes targets code utilization of the hardware by figuring out how to keep, excuse me, how to keep parallel execution units busy, filling delay slots. Although most algorithms for optimizations are NP hard heuristic techniques are well developed. Normally a compiler consists these three things: front end, middle end and back end. Front end is going to be checking what verify syntax and semantics. Middle end is going to be process useless or unreachable codes including removal of useless or unreachable codes. Backend generates the assembly code. Okay, so this is about compiler. Various compilers like ADA compilers, ALGOL compilers, basic compiler like C compiler, C++ compilers, okay, GCC, like every programming, like Java consists Java compiler. Every programming consists its own compiler, like which programming having compiler based programming language, those are all consist their own compiler. That compiler is responsible to check the syntax and the semantics. If you are violates as a programmer or users, violates generate compile time errors or compilation error. Okay, so this is about compiler. Okay, next one is interpreter. See, as we discussed, right, an interpreter is a language translator that programs line by line while the program is what running at runtime. See, these interpreters takes what single instructions as input. No intermediate object code is generated. Conditional control statements are executes slower. Memory requirements is less. Every time higher level program program is converted into what? Lower level program. Errors are displayed for every instruction interpreted. Okay, but in compiler, at a time it's going to be loads entire source code and converting what, and checking the syntax semantics and converting what source code into what object code. For that sake, there it going to be throws n number of errors at a time. But in interpreter, not like that. Interpreter is going to be errors are displayed for what? Every instructions interpreted. Okay, so this is about compiler and interpreter. In the previous video session, I explained in detail with the differences also. Okay, so this is a steps program execution involved in the interpreter. High level language consists what? Machine level language. Interpreter is also a language translator. Some languages only based on interpreter based programming languages are there. These interpreters are going to be converting high level language into machine level language and executing instructions step by step or line by line. If any errors, there only it's going to be generating errors. Okay, so examples like basic interpreters, Perl interpreter, okay, active TCL, VMS interpreters like Rex interpreters. These are all various examples about interpreters. And assemblers, as we discussed, assembler is a second generation uh, uh, assembler is a translator used in second generation like assembly language. Okay, assembler translates what? Assembly language instructions into machine language. See, as we discussed, these assembly languages, second generation languages, we are not using at these times. Okay, but anyhow, I given in detail explanation about what is assembler, what is assembly language, how it going to be translates what assembly language into machine understandable language, what type of mnemonics codes are used with examples I explained in detail with the previous video sessions. But if you go with the modern terminologies like macro assemblers, like macro instructions, like cross assemblers, high level assemblers like advanced control structures, in C language also we are using, like these conditions like if, then, else, do, case, and high level abstraction data types including structures, records, like unions, classes, and sets, like micro assemblers like micro program firmwares, meta assemblers, inline assemblers, or embedded assemblers. So these are all the terminologies used in what? Assemblers. Examples of assemblers like assemblers Intel x86 net right assembler. Okay, and also we discussed about what? Linker. Just only we discussed linker or link editor is a computer system program that takes what? One or more object file generated by a compiler or an assembler and combines them into what? A single executable file, library file, or another object file. So that is job done by what? Linker. It provides what? Runtime environment. If anything went wrong at runtime environment, there is a chances to rise runtime errors or linkage errors. Remember it. Okay, best example in the Unix commands like GNU linker. It consists static and dynamic linking. Object consists what? Object code is nothing but what? Machine understandable code. Source code is nothing but what? Programmer understandable code or user understandable code. Okay, next, relocation. Relocation is a process of what? Assigning address to the various parts of the program, adjusting what? Code and data in the program to reflect the assigned addresses. Okay, these two steps are involved in the relocation. Loader. Once linker is going to be generated executable code, loader is a part of an operating system that is responsible for what? Loading programs and libraries. See, it is one of the essential stage in the process of stating a program, as it places program into what? Memory and prepares them for execution. So just only we discussed, once linker is responsible to generating that executable code, loader is responsible to load that executable code from the secondary memory to the main memory, because CPU, central processing unit, always executes instructions presented in the main memory only. So that job is done by what? Loader. Okay, loading is a process of bringing a program from what? Secondary memory to what? Main memory, so it can run. The system software were responsible for it is known as a loader. Okay, simply you can understand, a loader is a system software that places executable programs, instructions, and data from secondary memory into primary memory and prepares them for what? Execution, and initiates the execution. So that is done by what? loader. See, these are all the terminologies we discussed in detail about process of compilation, like source program to machine understandable code, that is done by in detail process of compilation, like lexical analysis, syntactic analysis, semantic analysis, intermediate code generation, code generations. Okay, after that it going to be successfully generating what? Object code. Okay, this object code is understood by the machine. Source program is understood by the programmer or user. Okay, see, this is the source code translation into what? Executable code. Source program, what we write the program based on the particular programming language. Using C language, we are writing C instructions constructed and providing a solution of the particular problem in the form of what? Set of instructions written in the source program that convert source program into machine code. Sir, why we need to convert from high level instructions into machine level instructions? Because high level instructions are understood by the programmers or end users. Machine cannot understand these high level instructions. Machine always understands what? Zeros and ones representation only, or binary data or binary digits. Then every time a programmer or user cannot convert that high level instructions into machine level, that is very tough job. That is what we discussed in the first generation programming languages, right? For that sake, here language translators are there, like compiler. The compiler translates these high level instructions into what? Machine understandable instructions. When errors, compile time errors, compilation errors are free, then only compiler converts these high level instructions into machine understandable instructions, are called object code. Who is responsible to load that object code? Up to here, compile time environment. From here, runtime environment, right? Linker is responsible to load this object code and linking with the libraries and generating what? Executable code. Who should execute this code? Normally by processor, right? CPU, central processing unit. Then who should tell this code is ready to execute? That is done by what? System software is called loader. Loader is responsible to load this executable code from the secondary memory like hard disk to the main memory like primary memory is RAM. That is done by what? Loader. Then CPU once identifies that instructions into the main memory and start for executing that instructions, and we may get what? Output. Okay, that's it. So this is the general flow of source code translation into executable code for what? All the high level programming languages. But here some is going to be included, some is going to be excluded based on the particular programming language. Okay, fine. See, that's it. So in this session, we had discussed in detail about what is compiler, what is interpreter, what is assembler, and what is linker, what is relocation, and what is interpreter. And the job of all these terminologies we had discussed in detail with the process, execution, compilation, and also translating source code into what? Machine code or executable code. See, that's it for the today's session. Okay, see, thank you for watching my videos. Thank you all.